Welcome back, viewers. In this part of the video, we will be discussing the contribution of the number of particles to the particular unit cell. A crystal lattice is made up of very large number of unit cells. Since each unit cell touching one another, every lattice point is occupied by one constituent particle. Thus, constituent particle present at the lattice point may be shared by a number of unit cells. Now, we will be discussing the contribution at the different sites. Now, in case of corner atom, the atom which is present at the corner is equally shared by 8 other unit cells. That is 4 from the layer below and 4 from the layer above. Therefore, each corner atom contributes only 1 upon 8 atom to a particular unit cell. In case of face-centered atom, a face-centered atom is equally shared by 2 other unit cells. An atom present at the center of the face of a unit cell contributes 1 upon 2 atom to the unit cell. In case of a body-centered atom, since the atom is present inside the body, it contributes fully to the unit cell. In case of the edge-centered atom, the atom which occupy at the center of each edge is shared by 4 different unit cells, that is 2 from the layer below and the 2 from the layer above. Therefore, its contribution becomes 1 upon 4 of itself to the unit cell. With this calculation, we will be proceeding to the number of atoms calculation. In case of a primitive cubic unit cell, that is nothing but a simple cube, students, here particle will occupy at the 8 different corners. There is 1 atom at each corner of the cube. And since each corner atom is shared equally by 8 other unit cells, hence each corner atom contributes 1/8 atom to the unit cell. Therefore, number of atoms in a simple cubic unit cell is 8 corners multiplied by 1 upon 8 as the contribution, that becomes 1. Therefore, a simple cubic unit cell contains 1 atom. In case of a body-centered unit cell, here what will happen, along with the corner particle, one of the atom will occupy at the center of the body. As you already know, the contribution at the corner is 1 upon 8. Since 8 corners are there, multiplied by 1 upon 8 as the contribution, it becomes 1 atom per unit cell, and one which is present at the center of the body is not at all shared. Therefore, it contributes a whole to an atom. Hence, the number of atoms per body-centered unit cell is 1 atom from the corner, 1 atom from the body, that becomes 2. Here is the calculation. 8 corner atoms with the contribution of 1 upon 8 atom per unit cell, that becomes 1 atom. And 1 body-centered atom which is not at all shared, which contributes wholly to the atom, that becomes 1 atom. Therefore, number of atoms per unit cell of body-centered cube is nothing but 2 atoms per unit cell. Now, in case of face-centered cubic unit cell, here along with the corners, some particle will occupy center of each face. As you already know, 8 corner particles, its contribution is 1 upon 8 to the unit cell. Therefore, corner particles, 8 corners multiplied by its 1 upon 8 as the contribution, that becomes 1 atom. And 6 face-centered particle with the contribution of 1 upon 2, that becomes 6 into 1 upon 2, that becomes 3 atoms per unit cell. Therefore, 1 atom from the corner and 3 atoms from the face. Therefore, number of atoms becomes 4. Here is the calculation. 8 corner atoms multiplied by 1 upon 8 as the contribution, as you already know, that becomes 1 atom. 6 faces centered atom multiplied by its 1 by 2 contribution per unit cell, that is 6 multiplied 1 upon 2, that becomes 3 atom. Therefore, total number of atoms per unit cell of face-centered cube will be 4 atoms per unit cell. Thank you for watching.